My name is Jesse.
And my name is Severe. In this video, you'll see our latest cybersecurity solution for power substations.
Now, before we begin, let's cover some basics. So the poster behind me is a simplified diagram of the power grid. The electricity we all use is generated from the power plants in the left-hand side, then delivered to consumers through the transmission and distribution networks. The whole grid is made of substations and power lines. The major parts where cybersecurity is applied is substation automation systems. So here we have a more vivid model to represent the power grid of a city. It includes a power plant, the high voltage substation, the low voltage substation, and the industrial and residential consumers. As an industrial networking solution provider for power automation, we care about cybersecurity. So next, we want to show you what are the possible attack scenarios to substations and what are the countermeasures that we could do to prevent it from happening.
This is a simplified substation network architecture. The key component here is intelligent electronic device. Its job is to protect the primary equipment and power grid from damage caused by voltage, current, or frequency anomalies. Modern IEDs are connected via Ethernet networks to each other as well as to the SCADA system, which is a human-machine interface for operator to control the entire facility. So these two components, IED and SCADA, are the most critical and could be the primary cyber attack targets. The attack vectors may include compromised WAN links, as well as internal attacks through removable medias or other unauthorized devices. Let's see what may happen if adversaries get access to the substation network. We have built a test bed consist of 2 IEDs, a SCADA server, which are connected through Ethernet switch. Also, we have an additional cybersecurity appliance here, which we will introduce later. The first example is to trick the IED to trigger its protection. Let me use my attack tool and target IED. As you can see, the residents of this city are going to have a romantic evening with candles. The target for second example is SCADA. What I can do here is to disrupt its operation. This will leave the substation personnel without control, making it much harder to handle the incident. I think you all agree that these examples showed serious impacts. So let's take a deep dive into what exactly happened and how we can prevent it from happening. In the first scenario, I exploited the IED to IED communication protocol, which is called Goose. It is used for one IED to report its status to another IED, so protection functionality can span across different areas of the substation. If there's a failure in one bay, the other bay's protection should react accordingly. Goose was originally designed unencrypted because of its time-critical nature. There is an additional standard which implies digital signing of Goose messages. However, it's not widely adopted yet. Also, for time-critical reasons, Goose uses multicast transmission. So it's easy for an attacker to sniff messages, study its contents, and forge a malicious packet that mimics IED announcement about failure. This is exactly what I did with my attack tool during the demo.
It's not practical to put firewalls between IEDs because it will add unacceptable latencies. So our solution is based on Ethernet switch. Moxa PT series provides a special feature which is called Goose Check. It recognizes Goose protocols, remembers legitimate flows, and detects tampering activities. During the commissioning stage, we can verify that all Goose flows are legit via the switch user interface. Then, we can lock it by enabling Goose Lock and tell the switch to drop abnormal Goose messages.
Now let me try to run the same attack again. As you can see, nothing happens, and our happy residents can keep watching TV.
This is because the switch successfully detected the tampering attack and dropped malicious packets. Although the attacker created identical packets to the packets that the IED was sent in the case of a failure, the switch knows that they are coming from a different physical port, which triggers tampering detection and filters the malicious messages out. Such filtering is performed on a hardware level, so it doesn't add any latency. By the way, the goose check feature can also be used for troubleshooting because it provides some information about the flows.
During the second attack, I exploited a known vulnerability of SCADA computer's operating system. Actually, SCADAs usually run on top of Windows. In other words, they are similar to our home and office computers. The difference is, however, that they are not patched regularly. This is because any change in critical automation systems has to be verified and approved. So you can find many outdated software in the field. In this example, we have an unpatched Windows 7 computer, so I was able to use a publicly available exploit for RDP protocol and easily cause the whole system to halt.
To overcome these challenges, we can put in additional protection like IPS in front of SCADA computers. It can provide a function called virtual patch. The majority of vulnerabilities are executed through the network. So if we deploy IPS empowered with threat intelligence about known vulnerabilities, we can prevent the exploitation by dropping traffic related to the attack. In other words, we may delay patching of vulnerable systems by applying a virtual patch on the IPS. Having introduced the IPS, let me show you how it works. This is a web user interface of EtherCatch, IPS from Moxa. By sliding the toggle, I'm enabling pattern-based protection against OT and IT attacks. By the way, the patterns are updated regularly to keep up with the latest security advisories.
Now that the protection is on, let's try to execute the same attack one more time. As you can predict, the SCADA remains fully functional because the attack was blocked.
This can also be seen in the logs of the IPS unit. In addition, EtherCatch provides you OT protocol-aware firewall functionality to further strengthen your network security. Moxa provides a wide range portfolio of IEC 61850 compliant products for power automation. In the brief demonstration, we showed you some security features of Moxa solutions.
For more details, please visit our website at www.moxa.com/security or contact our partner in your region. Thanks for watching and see you next time.